Okay, class. Good morning, one alpha. Can you hear me?
Yes,
Okay, thank you. And then can you see my presentation, my slide?
yes.
Okay, very good also. Okay, good. All right. Can we start the class now, or you want to wait for other couple of minutes or what? Now is 7:57 in the morning, so I think I will start the class right now, yeah? How many of you already joined the class? How many here? Okay, never mind. I will check this. Okay, never mind. Right. Okay, before we start, make sure you already we just do a bit of the revision on the first topic, chapter 6. Okay, you must remember number one. Okay, in early topic of 6.1, the classification of element, you must remember that remember what's the meaning by atom, and then what is the meaning by molecule, and then you already must understand what is the meaning of element, right? And then what is compound, and then the example of element inside the periodic table. All right, and then the differences. The last topic we learned the differences between metal and non-metal. Okay, metal and non-metal is one of the element found on the earth, right? If I can write the what we call the summary, what that we have already learned in 6.1, right? Okay. All right. Okay, number one, we learn about atom. Yeah, number one, we already learn about atom. Can you see my writing?
Yes.
Atom, or we call it a particle. Particle inside the matter. We already learned about matter in chapter 5, right? Consists of particle. Okay, and then matter, how many condition of matter you already learned? We have liquid, yes, very good, and then solid, and then
Yes.
gas. Okay, and then you still remember the arrangement of the liquid, solid, and gas. Make sure you remember the what we call the particle or the atom arrangement. Okay, this is for example solid, and then this is sorry, I is wrong here. I just erase it a bit. You start from okay, this one is solid, right? This one is solid, and then this one is liquid and gas. Okay, liquid is just this, gas is just like this. Okay, the arrangement of matter. Okay, and then inside in chapter 6, okay, each of the particle here, or we call it atom, is the single particle or the single and small individual atom. This is also we call by atom. Okay, can you understand this? Right? So this is atom. And then inside atom, inside the individual atom, if I can get the atom out, okay, inside the individual atom, we have, you must understand the subatomic particles, okay, meaning that the parts inside the single atom. This one is, if I take the single atom out, all right, inside the single atom, we have what we call the subatomic particle, consists of what? Consists of proton. Can you understand this? Proton, and then neutron and electron. Okay, for example here, if I can draw the example of subatomic particle, is just like this. Okay, this is what we call the structure or the structure of atom. Okay, this is structure of atom. Make sure you understand which one is proton, which one is neutron, and which one is electron. Electron is here. This is electron. This is electron, and then proton and neutron is what we call by nucleus. Nucleus, and then proton is inside at the center. Okay, proton and neutron. Okay, can you understand this? Right? And then next one, you learn about the molecule. Molecule. What is different between molecule and atom? Okay, same element. Okay, for example, molecule consists of two or more atom. For example, if I use hydrogen element, this is element, and then atom consists of only single atom. So this is molecule, and then this is atom. Okay, can you understand this? Right. And then what is an element? An element is what we call the simplest form of substance, meaning that it cannot what we call it cannot divided anymore. For example, the example of element is hydrogen here. Okay, if I take one of the element here, this is the simple one of the element, we call it H, or hydrogen. Hydrogen. Hydrogen here is the simplest form of element. Can you separate it? For example, if I want to cut the atom into half, one over here and then one over here, is it possible? Can or cannot? Can or cannot I split the element, I split the atom into two. I split the atom into two. Can or cannot? For example, hydrogen over here. Okay, never mind. Okay, for example, I have one atom over here. One atom. Okay, this atom name is hydrogen. H meaning hydrogen, right? H is hydrogen. Okay. I want to split in half. I want to split it in half. Okay. Can or cannot? Is it possible or not possible? If I want to split, I want to split the atom to half. Can or cannot?
Can.
You okay. You cannot you cannot split the atom in half, because the atom here is one of the what we call the simplest form of substance. Okay, you cannot split the atom into half. So this is what we call element. Okay, this is what we call an element. Okay, example of element. What are the example of element? If you look at the textbook, for example, we have ferrum, Fe. Fe is ferrum. Ferrum, or we call it iron. Okay, the another element such as Zn. Zn here, this is zinc. Zinc. Okay, for other elements such as H. H is hydrogen. H is hydrogen. Okay, this is example of element. Okay, how many elements inside the earth? How many elements found in the earth? Where do you want to find? Where do you want to find the rest of the element? You can refer to what table? Periodic table. Okay. If you want to take a look, the rest of the element, actually there are right now there are about 100 known element in the earth. Okay, 118. Right. You do not need to remember all these elements, no need, okay? But you must able to remember a few elements such as what? Hydrogen, zinc, ferrum, oxygen, carbon, magnesium. That's just a very common element. We say that, common element. Okay, if you want to look, if you want to look at other element, you can refer to the periodic table. Okay, because periodic table is already, they try to arrange the element into the name, into their proton number, their symbol, the name of the element, and the relative atomic mass. Okay, you can refer back to your textbook, page 167. Right? So this is what we call by element. Okay, what is compound? Okay, what is compound? Compound is two or more. Two or more what, class? Two or more?
Element.
Okay, good. Two or more element. Two or more element combine chemically. For example, the example of compound is water. Water is the basic, what we call one of the compound found on the earth. Because water has, if I try to draw the molecule of water, the compound of water, not the molecule, sorry, the compound of water, if I try to draw it, it contain H2O. Okay, it contain one atom of what? And then two atom of?
Hydrogen.
Yes. This is if you draw the compound of water, okay, it consists of what we call one atom of oxygen and then two atom of hydrogen. So the formula for water is H2O. Okay, H2O here is the formula, chemical formula for water. When you go to Form 4, Form 5, if you take chemistry, you will be learn about this more. Okay. Okay. Example of the compound is H2O, or the water. Right. So if you look at the what we call the symbol or the drawing of the atom of water here, it consists of what? It consists of two elements. H here is hydrogen, and then O here is oxygen. So meaning that it is combined chemically. If you look at the picture over here, right? You look at the picture over here, the picture of the atom here, it combined chemically, right? So my question is, what happened? Can I split the oxygen here and the hydrogen here? Can I split the hydrogen out of the water here, for example? Can or cannot?
Can.
Okay, all right. So, okay, the answer is, if I want to split the hydrogen from the water compound, yes, I'm able to do that. Okay, meaning that we can separate the element. We can separate the element. If we want to take out the hydrogen from the water formula, yes, we can do that. Okay, but element we cannot. For example, here, if I can draw one element, element of hydrogen lah, element of hydrogen, for example. If I want to split in half, cannot. Okay, I cannot split the what we call the atom in half. But compound, I can split or I can separate the element into, I can extract, not to split, not to split in half. I just want to extract the element from the compound. Yes, I able to do that. But if you want to split the element into two parts here, cannot. This one cannot. Right? Can you understand this? This is example of compound. And then So others compound is, for example, what is the others compound name? Okay, for example, carbon dioxide. What is carbon dioxide, class? Carbon dioxide is the gas, right? We breathe in oxygen and then we breathe out carbon dioxide. You already learned that, right? Kamu sudah belajar itu. Keluar gas, carbon dioxide. So carbon dioxide is a compound. Okay, consists of what? Consists of element carbon and then element oxygen. Carbon dioxide. Okay, and then the formula of carbon dioxide is CO2. The formula name for carbon dioxide is CO2. If you can what we call draw the what we call the structure of carbon dioxide is just like this. Okay, we have two oxygen atom and then one carbon. This is carbon dioxide. So carbon dioxide also what? Also is the example of compound. Okay, right? Can you understand this?
Yeah.
Okay, next one is periodic table. You can read the periodic table over here, no problem. You have any question, you can ask me about the periodic table. No need to memorize all the known material over there, all the known element, no need to memorize, but you must understand the what? The structure, okay, or the arrangement of the element inside the periodic table. Okay, and then last time we learned about the difference between metal and non-metal. Okay.
Teacher, you have closed the mic.
Sorry. Okay. Okay. It is accidentally closed the mic. Okay, very good. Thank you for telling me. All right. So page, can you hear my voice now? Can you hear my voice now?
Yeah.
Okay, very good. Sorry. So in textbook page 172, there are a few activity for us to study the characteristic of metal and non-metal. Okay, maybe we try to do this experiment after we all come back to the school, but actually, all right, the experiment is very straightforward, just to study the characteristic of metal and non-metal. For example, if you look at my presentation right now, page 172 in your textbook, this is the what we call to study the characteristic of metal and non-metal. Okay, so of course, if you look at the picture right now, we have two types of copper. One is copper rod and one is carbon rod. So which one is the metal, copper or carbon? Which one is metal, copper or carbon? We have number one, copper rod. We have number two, carbon rod. So which one is metal, carbon or copper? Hello? Can you hear my voice?
Yeah.
Which one is which one is metal, copper or carbon? Number one or number two?
Copper.
Okay, copper is metal, right? And then carbon rod is non-metal. That's why first you need to try to identify, or you try to recognize which substance is metal and which substance is non-metal. So copper is the example of metal. This is the example of metal, and then carbon over here is the example of non-metal. So if you try to use sandpaper and then you try to rub it very vigorously, you can see that the surface of the copper become shiny. Okay, the surface of the copper becomes shiny if you rub it with the sandpaper. And then what happened to the surface of the carbon? The surface of the carbon is dull. It's very dull. It cannot be shiny. Okay, it is not shiny. How strong or how vigorous you try to rub the surface of carbon with sandpaper, right? The surface is still dull. Okay, meaning that which one is what we call the appearance of the metal. Okay, copper shiny and then carbon is dull. This is number one, the first characteristic of metal and non-metal. Can you understand this? Very straightforward, right? Okay, very good. So next one. All right. So in this picture, okay, if you try to bend the copper wire, can bend or cannot bend? This is the ductility, right? Okay. Copper wire, it can bend. So this is what we call the ductility. You still remember the ductility? Okay. This is copper wire. Copper wire, if you try to bend it, right? If you try to bend the copper wire, yes, it can bend. Right? It can bend. Right? But what happens if you try to bend the pencil lead? Pencil lead here actually is made from carbon. Carbon is metal or non-metal? Carbon is non-metal. Okay, copper here is metal. So what happens if you try to bend the pencil lead or the carbon? It will what happened to the pencil lead if you try to what we call bend it? It will break into, right? It will break into two. Yes. It will break into two, or it will snap. Okay, it will snap into two. Okay, so the ductility here, metal, the metal is what we call ductile. The metal is ductile, and then the non-metal is non-ductile, meaning it can break. Okay, copper or the metal can bend. This is what happened to the metal. When you try to bend it, it can bend, or it is ductile. For non-metal, usually it will break. It is non-ductile. Okay. Right. Next one. Okay. This one is malleability. This one is what we call by malleability. How to what we call to write it, to spell it, malleability. Malleability, meaning that it can hit into we can what we call turn it into shape. For example, if I use hammer and then I try to hit it with an hammer, it can be shaped into, it can be formed into different shape. So this is malleability. All right. If I use iron, okay, iron is the piece of metal. When I hit it with hammer, it can be shaped. So this is malleability. If I use what we call carbon, it will break. It will shatter. Okay, so we can say that metal can, the malleability is malleable. Metal is malleable. M-A-L-L-E-A-B-L-E. E-L-L-A-B-L-E, malleable. Malleable meaning that if you hit with a hammer, it can be turned into shape. All right, it can be turned into shape. Any shape you want. You want to become square. You want it to become sphere. You want to become round. You want it to become triangle. Any shape you can what we call, you can turn the iron, or you can turn the metal into any shape, but not with what? Not with non-metal. For example, carbon. Carbon, you cannot heat it and then turn into shape. Okay. This is what we call by malleability. Next one. Can you follow me? Is it okay?
Okay.
All right. So this one, the conductivity of electric. Okay, I already explained you this. Okay. If you use iron rod, yes, iron rod is a metal. Okay. Iron rod is the example of metal. Of course, it can conduct electricity. Okay. What happened if I change the iron rod here? I'll change it to glass. Okay, I will change the iron rod into glass, and then I switch on the power here. The emitter here is working or not? If I replace the rod with glass rod, the emitter is have reading or no reading? Class?
No.
Have okay, never mind lah. I just change the emitter here into bulb. B-U-L-B. Bulb mean apa? Lampu kan, lampu. Okay. I switch on the switch. Switch on the switch over here. I switch on the switch, and then the bulb here light or does not light?
Not light.
Okay, it will not light. Okay, why? Because glass is metal or non-metal?
No.
Glass is non-metal. So non-metal can what we call can conduct electric or cannot conduct electric. Dry cell here is battery. Also we call it battery. Okay, non-metal. Okay, for example here I use glass rod. Glass rod here cannot conduct electricity. So when I replace the glass rod over here, and then I turn on the switch, the bulb here will not light. Why? Because glass rod cannot conduct electricity, because the glass rod is made from non-metal. Okay, but there are one non-metal that can conduct electricity. What is the name of the non-metal? There is one non-metal can conduct electricity. What is the name of the metal? Sorry, what is the name of non-metal? What is the name? One non-metal can conduct electric. Only one non-metal. Non-metal. What is the name of the element? What is the name of the non-metal? Start with C. Start with C, class. What's the name of the non-metal that can conduct electricity or able to conduct electricity? You must remember, yeah?
Carbon.
Yes, very good. Thank you very much. It is a carbon. Only non-metal carbon can conduct electricity. So if I switch on the switch here, all right? I switch on the switch, what happened to the bulb? Light or not light? What happened to the bulb over here? It will what? The bulb will be light. It will be lighted. Can you understand? Can you understand this? If I change it, yes. Okay, thank you. If I change it to carbon, it can be lighted. Okay, right? Can you understand this? What happens if I change it to copper or aluminium? Aluminium. Aluminium rod. Aluminium rod, metal or non-metal?
Metal.
Metal. Okay, so if I switch on, what happened to the bulb? Light or not lighted?
Lighted.
It will be
Light.
light. Yes, very good. Okay, that is example of what we call the conductivity of electricity. Okay, next one. Okay, this is the what we call the conductivity of heat. Okay, I already explained it in my last video. Make sure you can understand that. Okay. Okay, last, I want to explain this last. The conductivity of electricity, at the picture over here, using carbon rod. Carbon rod is metal or non-metal class? This is non. Last, this is this is non-metal. All right. And then here we have a source of fire here, the source of heat here. This is, we use candle as the source of heat. Okay. And then wax over here. What happened to the wax when there is a heat? When there is a heat, the wax here will melt and then the thumbtack will drop. Okay. When there is heat, okay, the wax here will melt and then the thumbtack will drop. But first we use carbon rod. Okay, first we use carbon rod. Okay, and then maybe after, okay, maybe after, for example, maybe after 1 minute. Okay, if I use carbon rod, after 1 minute, the thumbtack will drop. Okay, will drop in 1 minute. Okay, drops in 1 minute. Can you understand me? Can you follow me? Can you follow me? Because the heat over here will move, will conduct. Okay, in 1 minute, the heat will travel along the carbon to the wax, and then when the wax melt, the thumbtack will drop. This is for carbon rod. Can you understand me?
Yes.
Can? Okay. What happened? I use the same setting, but I change the carbon rod to copper rod. Can you follow me?
Yes.
I use I will replace the carbon rod with copper rod. Same setting, all right? Same heat, same wax, same thumbtack. And then what I find out is, okay, copper rod is what? Copper rod is metal. And then the result is the thumbtack, if I use copper rod, the thumbtack over here will drop in 20 seconds. Can you understand this? Will drop in 20 seconds. The thumbtack here drop in 20 seconds. 20 seconds only it takes. If I use carbon rod, it drops in how many? What's the time? Yes, if I use carbon rod, the thumbtacks here will drop in 1 minute. But if I use copper rod, it will drop in just 20 seconds. So what is your conclusion about this? Which substance, metal or non-metal, has a very good heat conductivity? Heat conductivity, which one, metal or non-metal?
Metal.
Metal has, very good. Your answer is correct. Metal has very good heat conductivity. Meaning what? Meaning the heat from the candle here will travel inside the rod much faster than non-metal. Okay, from here, right? From here, from the heat of the source to the wax here, for non-metal, very slow, very poor heat conductivity. But if you use metal, the heat travel very fast. So meaning that metal over here, metal has a good heat conductor. Okay, for non-metal, we have what is the characteristic? Is the poor heat conductor. Can you understand the explanation here? Can you understand it? Right? Because the time, what we call the time heat travel from here to here, okay, if you use metal, much faster. If you use non-metal, very slow. One metal, about 1 minute, then the wax here will drop. The thumbtack will drop. But if you use copper rod, if you use metal, it just take about 20 seconds for the thumbtacks to drop. So this is the heat conductivity. Okay, class? You understand it?
Yes.
Okay,
Sure.
never mind. All right, I think I will stop here. We'll try to continue the next topic next week on Monday. On Monday. All right, and then if I have any exercise, I will give the exercise in our Telegram groups. Okay, if you have any question also, you can also ask me in the Telegram group. So can we stop here? Yeah, I think I will stop my class here. Okay, so thank you for your attention and focus lah. Yeah, we all meet you again next week lah on Monday. Okay, anything you just message me on our Telegram group. All right? Okay, class. Is it okay? Okay. Okay. All right. See you next Monday. Thank you. You can leave the class now. Bye bye.
Thank you, teacher.
Yeah. Thank you very much.